Alright guys, so I'm gonna go ahead and walk you through completing this handout. Okay, so you should have received the handout from the sub. So what I'd like for you guys to do today while I'm gone is follow along on the video, and I'll walk you through how to fill it in, and we'll review a little bit of the topics that I wanted you to observe in Desmo's activity. Okay, so let's go ahead and get started. So we're going to start with the three major types of transformations, which are translations, dilations, and reflections. Okay, those are the three primary parts to transformations. All right, so let's start with the vertical shift. Okay, vertical shift, if you notice, is just one of the two different types of shifts that you are likely to see. Okay, vertical shift occurs when some value, some constant, some number is added or subtracted to the end of the inequality. I'm sorry, not the inequality, the absolute value. Okay, so in this case, right, if you take a look down at the bottom, there is a section that asks us to write what would a vertical translation up 3 units, what would it look like? Okay, so this is pretty simple. You would begin by writing the parent function, which is y equals absolute value of x. And if I want to shift something up, then I would add 3 to the end of the absolute value. Okay, so it's pretty simple. I just add 3. Okay, so to walk you through how the graph would look like, if this was the original parent function, we know that the origin 0, 0 would be the vertex. But in this case, because we shifted the whole function up 3 spaces, then our vertex is not going to start at 0, it's going to start at positive 3. Okay, so let me erase this part. I'll zoom in a little bit. Okay, so I know that what I'm graphing here, let me rewrite it, is y equals absolute value of x plus 3. Okay, so since this is my vertex here, 0, comma 3, then what would come next is to find some additional values to be able to draw the rest. Okay, so you could create a table of values, okay, but I don't really want to do that because I want to go through it quickly and I want to be able to just sketch what the absolute value graph looks like without having to create that table. So one of the things and one of the tricks that I have found is that if you imagine the absolute value as being the equation of a line, right? If I were to get rid of the absolute value bars, notice how it's simply y equals x plus 3. Now, if you think back to Algebra 1 days, if there is no number in front of x, that means that there's an invisible 1. And if I have a whole number, I can always make it a fraction by putting a 1 underneath. So I hope that that reminds you of, right here, of a slope. And that slope, remember, is just rise over run. So if I take the absolute value bars out, I notice that this line, one of the two lines that makes up the V, is going to have a slope of 1. So if I go up 1 and to the right one, and then up 1 to the right one again, right, follow that slope, that's going to give me my V. Right, I could keep going if I wanted to, but that gives me that first leg. Okay. Now, you guys know that the V is supposed to be symmetrical. Okay, so that means that it has two equal parts. So if I want to graph the line that's on the left side now, then what I would do is follow the slope but go backwards. So I would still go up 1, but now I go to the left. Up 1 and then to the left. Up 1 and then to the left. Okay, so then that helps me create a quick little sketch of where this function is going to be, right? So I shifted it up 3 units and there it is. Okay, let's take a look at the next one. Now we're looking at a shift down, right? So what we call that is a vertical translation. Whoops, let me erase that. It's a vertical translation down 4 units. Okay, so then I'm going to draw the equation that represents that. Okay, so in this case, what I'm looking at is still y equals absolute value of x. It's the parent function, but because I'm going down, okay, down represents use a minus sign, just like up represents use a plus sign. So here I want to subtract 4. Okay, so now, okay, I want to graph this. I want to graph the pink one, so I'm going to erase this so I can have it in front of me. absolute value of x minus 4. So the same idea here, right? If originally my vertex would have been there at the origin, well, now I have to move down 4 units. Whoa, I don't want that. Move down 4 units, and that's where my vertex is going to be. Okay, the same idea now. Okay, I want to be able to sketch this quickly without having to make a table of values. So I can simply drop the absolute value bars and just take a look at it like this. X minus 4. So once again, since there's no number in front of the x, I can draw a 1 over 1. That tells me the slope of my absolute value. Okay, so I can use that to create a quick little sketch. So up 1 to the right, up 1 to the right, up 1 to the right. Okay, there's half of my absolute value graph. Okay, just want to label my vertex real quick. I can do the same thing now, follow that same slope, but I want to draw the other side, so then I go backwards. So up 1 and then to the left, up 1, left, up 1, 1 left. Okay, and there it is. There's a quick way to be able to sketch. Okay, sketch it because we're not using a formal table. So that gives us an idea though of what happens when you shift up or you shift down. Okay, so those are our vertical translations. Okay, let's take a look now at the horizontal shift. So the horizontal shift is slightly different because when you see a horizontal shift, notice that the change is happening not outside but inside. Okay, so I see right here, it's a plus h or a minus h, right? I have both options because I can shift to the right or I can shift to the left. So in this case, if I want to graph the horizontal shift of a absolute value, okay, first let's see what we're being asked to do. Okay, so we want a horizontal translation right of 5 units. In this case, I take y equals absolute value x. Now, in this case, it's backwards. If I want to go to the right, okay, if I want to go right, I'm going to use not a positive, but I'm going to use a negative. Okay, so I actually want to write this as x minus 5. Okay, I know it seems counterintuitive because if you're moving to the right, that's where the positive numbers are at. But it's the opposite. So we're going to go x minus 5. All right, so let's take a look at the graph and how we can start drawing it. So remember that if this was where the original would have started, if that's our origin, then we're going to move to the right 5 units. So I'm actually going to start right here. Okay, so my vertex is 5, 0. Okay. And now, same thing, right? Notice how I don't have any value out here in the front. Okay, so I know that all that happened to my parent function was that I shifted it 5 units to the right. It didn't get scaled up, it didn't get compressed, so it's not going to grow any faster or it's not going to grow any slower. So if your parent function has a slope of 1, so does this one. Okay, so again, quick sketch, up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. Okay, create a quick graph, and now I can do the same thing going to the left, up 1 to the left, and so on. Okay, so now there's my V. Okay, so there you can see that rather than starting in the middle or the center or the origin, it's going to start 5 spaces to the right. Okay, that's where our vertex will be. Okay, now let's take a look at what happens if I want to shift in the other direction. Let's say I want to shift left. Okay, so now if I want to shift left, then I don't want to use negative, I want to use positive. So if I'm moving to the left 2 units, I'm going to write y equals absolute value of x plus 2. Okay. All right, so let's see how that graph is going to look like. Let me use a different color here. Okay, so I want to move 2 units to the left, so my vertex will shift 2 units towards the negative side. And then just like before, since the absolute value function, since the parent function, right, our parent function is y equals absolute value of x, since it hasn't changed, we're not scaling it, we're not stretching it, we're not compressing it, it's still going to grow at that same rate, which is up 1 and to the right 1, up 1 to the right 1. Okay, so there's half. with a vertex of negative 2, 0. And then I want to do the other side as well. So up 1 to the left, up 1 to the left, up 1 to the left. And there it is. Okay, so you can see the difference there. What happens if you add a value? If you add a value, you're actually moving to the left. If you subtract a value, like we did here, then you're moving to the right. All right. Okay, now we move on to the vertical stretch, which is also known as a dilation. Okay, so if you notice the key word up here, dilation. All right, so one thing to keep in mind is that the size of the number in front of the absolute value matters. Okay, so if a is larger than 1, okay, so let's say we have a number here where a is, if that number happens to be something bigger than 1, so let's say for example 2, 3, 4, 5, whatever, it's going to stretch, which means it's going to look more narrow, it's going to look like it grows faster. The opening between the two lines is going to be smaller, so it looks like the lines are closing together. Okay, so it's real simple to write it. First, what you want to do is start with y equals. Instead of a, okay, you're going to write the number. So in this case, it's a factor of 4. So I'm going to put 4 and then multiply that times absolute value of x. Okay, so that's a simple way to write it. What changes here is it doesn't shift left or right. Instead, it stays put. Okay, we haven't changed the vertex, so it still starts here at 0, 0. However, okay, because of the fact that you just multiplied everything by 4, right, that's what it represents, 4 times absolute value of x, then what's happening now is that your line is growing 4 times as fast. Okay, so let's say I want to see what kind of line it creates. So let me rewrite it as y equals 4x. Right, this is the same trick that I used before. I want to see what the slope is going to be. So I want to put a 1 underneath. I want to see what the slope is going to be, so I can say, all right, that's a 4 on the top, so my rise is 4, and then I run 1. So up 4 to the right 1, up 4 to the right 1. Okay, I can also do the same thing, but to the left. So up 4 to the left 1, up 4 to the left 1. Okay, so I start at the vertex, and I connect those points. Sorry, I don't know why it's moving around on me. Okay, so let's go ahead and draw that line, connect these 3 points, and then we connect these 3 points. Okay. Alright, there it is. There's our vertical stretch by a factor of 4. Now let's take a look at what a vertical compression looks like. Okay, the vertical compression is the opposite of a stretch. Instead of making it more narrow, it makes it more wide. So for example, in this case, we're looking for a vertical compression by a factor of 1/2. So if I want to write that equation, okay, pretty simple. I can say y equals 1/2 times absolute value of x. Okay, so because we didn't shift it left or right, I still have the vertex at 0, 0. And now we're going to use that trick. Y equals 1/2 x. I can use the 1/2 to help me because that's a slope. So then I'm going to say, okay, it's 1/2 x. Going to move up 1 to the right 2, up 1 to the right 2. Okay. And I can do the same thing going left, up 1 to the left 2, up 1 to the left 2. And there it is. Okay. So notice how wide this graph is in comparison to its brother over here, which is the vertical stretch, right? The vertical stretch is pretty narrow. It grows pretty quickly versus the vertical compression. It looks like somebody is trying to push the lines down, right? Kind of open it up, make it kind of like a book. Okay. And then finally, let's take a look at the last type of transformation, which is the reflection. The reflection is pretty easy. We've already kind of looked at it before. Okay, a reflection simply means you're going to flip the v across the x-axis. Okay, at least in this case, right? Because we're looking at a reflection across the x-axis. So when that happens and you're asked to describe it, you need to say that there was a reflection across the x-axis. Okay. How do you know that it's a reflection across the x-axis? Because the negative is on the outside. Okay, so there's a negative there outside the absolute value. Okay, so it's pretty simple. So let's say, right, I draw my parent function first. My parent function is y equals absolute value of x. That's pretty simple. I have a vertex here. It has a slope of 1. So I get a v that looks like this. So a reflection across the x-axis means just flip the v around. So then it's the opposite. Okay, so I would have a v that actually goes in the opposite direction. And there it is. Right, so that's what it means to have a reflection. Okay. Now, in terms of a reflection across the y-axis, this one is a little bit trickier. Okay, and I'm not going to discuss it in the video. We're going to talk a little bit about it once I get back. Okay, but I wanted to show you guys what the completed graphic organizer would look like. So now you can refer back to this, okay, and hopefully it will help you complete some of your homework. Okay, let me know if you guys have any questions. You can always message me through Schoology. I should have my computer available. My email will be available while I'm at the training. So if anything comes up, just send me a message and I'll try my best to reply as soon as possible. Okay, have a great day, and I'll see you guys after the 3-day weekend.